In this chapter, we shall study principles of counting that are needed in the understanding of probability. In this video, we shall define and give examples of sample spaces and events which are two key points to understand counting techniques. A statistical experiment is a process that generates a set of data. In counting techniques and probability, one should understand clearly the experiment situation. Usual statistical experiments includes tossing or rolling, drawing or selecting, and arranging of objects. In probability, one should count the number of possible outcomes of a statistical experiment. The set of all possible outcomes of a statistical experiment is called the sample space and is denoted by capital S. An element of a sample space is called a sample point. Examples of experiments and sample spaces would be tossing of a coin, in which the sample space contains the elements heads or tails. Second example would be tossing of a coin twice, wherein the sample space contains the elements head-head, head-tail, tail-head, and tail-tail. The third example would be rolling a die, wherein the sample space would consist of the numbers 1, 2, 3, 4, 5, and 6. Fourth example would be rolling a pair of dice, wherein the sample space would contain 36 possible outcomes, and the outcomes can be written using a tree diagram by listing down all the elements or all the outcomes for the first die, and for each of these outcomes, this would branch out into 6 additional outcomes for the second die. Now, the final output would be an ordered pair, wherein the first coordinate would be the outcome on the first die and the second coordinate would be the outcome on the second die. And then the last example for experiments and sample spaces would be drawing a card from a deck of playing cards, where the sample space would consist of all the 52 playing cards. Let us have another example. Consider the experiment of flipping a coin. If a head occurs, we flip the coin for the second time, while if a tail occurs, a die is thrown. This experiment consists of two parts. The first part is to flip a coin, which would result into a head or a tail. The second part would be or would depend on the outcomes on the first part of the experiment. If a head occurs, we flip the coin for the second time. So this head here will branch out into two additional outcomes, heads or tails. And then if a tail occurs, this will branch out into 6 outcomes corresponding to 1, 2, 3, 4, 5, and 6. So which are the outcomes of rolling a die. So the total outcomes or the possible outcomes can be written as follows. Head, 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 tail, and then we have tail 1 up to tail 6, which is written as follows. Let us have another example. Suppose that 3 balls are selected one at a time from a bag containing white and black balls. Let capital B represent a black ball and capital W a white ball. The sample point BBW is obtained from selecting a black ball on the first and second selections and a white ball on the third selection. To write the elements of the sample space, we can use a tree diagram. So for the first selection, it's either a black or a white ball. And then each of these would branch out into 2 additional outcomes for the second selection, which would result to either a black or a white ball. And then on the third selection, each of these will again branch out into 2 additional outcomes each, which corresponds to black or white balls. Now, following the path in this tree diagram will give us the elements of the sample space. In probability problems, we are expected to get the chance or the probability that a certain event will happen. Now, an event is a subset of a sample space, while a null event or null space is an event that is impossible to happen. The null event is denoted by the symbol empty set. To illustrate an event, let's have the following experiment. Suppose that we're going to toss two coins. The sample space of this experiment would consist of the elements head head, head tail, tail head, and tail tail. Now let us define the event capital E as the event of obtaining exactly two heads. So among the elements of the sample space, which of those elements would satisfy the requirement of the event E? And that is only the element head head. Now for the second example, experiment is rolling a pair of dice. In a pair of dice, there would be 36 possible outcomes, namely 1-1, 1-2, 1-3 up to 1-6, 2-1, 2-2, 2-3 up to 2-6, and so on and so forth until we reach 6-1, 6-2, 6-3 up to 6-6. Now let us define E as the event of obtaining doubles. When we say doubles, it means that the result from each of the die are the same. So therefore, the elements of the event E would be 1-1, 2-2, 3-3, 4-4, 5-5, and 6-6. Now this time, to illustrate a null event, it's impossible to get a number 7 when we throw a die. So therefore, this event is a null event. It's also impossible to get a heart card that is colored black in a standard deck of playing cards. Also, it would be impossible that there will be no January 1 in a year. Now you have learned about sample spaces and events. In the next video, you shall learn about the techniques of counting the elements of sample spaces and events.